a square plus a minus 0 bracket square. So it will get minus a square plus a square. That will write here under the square root a square plus a square. So what will we get? We have to find out that answer, that is root 2 into a units. Correct? So distance of AB, we have to easily find out root 2 into A units. So here our first question completed. That will get the total 8 marks. Then question number 2. So question number 2 is an activity type question. And here when we complete one box, we'll get the half marks. Total 4 box here. So we'll get the 2 marks each question. So what is the question? We have to discuss it. So focus on a second question. What is the given here? When we focus here 3 parallel lines concept is given. In the figure, AB is parallel to CD. CD is parallel to EF. If AC is equal to 5.4, C is equal to 9, BD is equal to 7.5, then to find DF. Complete the following activity. So focus on a diagram. Here we have to use the concept of application of BPT or 3 parallel lines and their transversal. Correct? So AB is parallel to CD is parallel to DF. We have to use the BPT or basic proportionality theorem. That is AC upon CE is equal to BD upon DF. What to be write here? Just focus here. We have to write here. Focus here. AB upon C is equal to BD upon DF. We have to use in box also. So we have to put that value 5 upon 4 upon 9 is equal to 7.5 upon DF. So calculate the DF, will get the answer 12.5. So here will be answer 12.5. Then focus on a second activity. What we'll get here? It is a trigonometry. Prove that question. Sin raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. So we'll take the LHS. So what is the LHS? Sin raised to 4 theta minus cos raised to 4 theta. It will convert here. Just focus here. It will convert here a square minus b square form. So what is the a square? Sin square raised to theta minus cos square theta. Correct? So we have to use that formula. A square minus b square is nothing but a plus b in first bracket, a minus b in second bracket. So we have to use here same formula, that is sin square plus cos square theta, and in second bracket sin square theta minus cos square theta. So we know our identities. What is the identities? Sin square theta plus cos square theta, that value will be 1. So in box we'll write here 1, and remaining sin square minus cos square theta as it is. Correct? But we know that again this activity is converted with relation of cos, that is sin square theta is replaced the value of 1 minus cos square theta. So that sin square theta is replaced the value of 1 minus cos square theta minus cos square theta. So here 1 minus cos square theta minus cos square theta, it become 2 cos square theta. So here we'll get LHS become RHS. What will you get here? LHS become RHS. So we have to prove that sin raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. Correct? Then focus on our third activity. So what is our third question? Find the volume of cone if the radius of its base is 1.5 centimeter and its perpendicular height is 5 centimeter. So what is the volume of a cone? We know that volume of the cone is 1/3 pi r square h. Then we have to put in box also. So 1/3, what is the value of pi? 22 upon 7. R replaced by 1.5 bracket square into 5. So here we have to calculate it. 22 into 1.5 square into 5, that is 3.75 upon 7. That answer will be 11.79 cubic centimeter. So our here activity type question will be completed. We have to focus on question 2b. Total 5 questions are given. We have to solve any 4. It will get the 8 marks, correct? Each question having 2 marks. So focus on question 2b1, first question. So what is the first question? Find QP using the given information is given. Here angle bisector diagram is given. Focus on that diagram. Here in triangle M and P. Just focus here. In triangle M and P, ray NQ bisect angle M and P, correct? By using angle bisector theorem. So what is the angle bisector theorem? We have to use Mn upon Np is equal to Mq upon Qp, correct? Put the given value. Mn is replaced by 25, Np is replaced by 40, Mq is replaced by 14, and we have to find out the value of Qp. So cross multiply it. So 25 into QP is equal to 40 into 40. So QP we have to find out that 25 is multiplied. Here we have to divide. So we have to divide it. It will get 112 upon 5. So what is the value of QP? That is the 22.4 units. So here we have to complete it first question 2B1. Then focus on a second diagram. So what is the question? In a figure, chords AC and DE intersect at B. If angle ABE is equal to 108 degree, measure of arc AE is equal to 95 degree, find measure of arc DC. Find measure of arc DC. So focus here, diagram. Here we have to use the chords intersect each other internally. So we have to use the formula angle ABE. Angle ABE is equal to half into measure of arc, half into measure of arc AE plus measure of arc DC. So put that given value angle AB is 108 degree is equal to half measure of arc AE measure is 95 degree and unknown quantity is measure of arc DC. So put that 2 is here. This is the divide part. When we change here multiply. So 108 into 2 that will get 216 is equal to 95 degree plus measure of arc DC. So 216 that plus 95 shift here it will get minus. So measure of arc DC is equal to 121 degree. Then focus here third question. So what is our third question? Focus here. In triangle ABC, segment AD perpendicular segment BC, angle C is equal to 45 degree, BD is equal to 5 and AC is equal to 8 root 2 centimeter. Then find the value of AD and AB. So focus here, it is a right angle triangle and measure of that right angle triangle 90 degree and 45 degrees. So we know that AD is the opposite side of a 45 degree. What is here AD? AD is nothing but when we observe the diagram, it is a opposite sides of an angle 45 degrees. So we know the relation 1 upon root 2 into hypotenuse. So opposite side is a 1 upon root 2 into hypotenuse. So 1 upon root 2 hypotenuse value is given 8 root 2. So root 2 get cancelled. So AD value is 8 units, correct? We have to find out the AD. Then focus here. We have to find out the value of BD also. So here AD and BD value is given. So we have to find out the value of AB by using Pythagoras theorem. So AB square is equal to AD square. See here. AB square is equal to AD square plus BD square. Put the given value. So AB square is equal to 5 square plus 8 square. 5 square that is 25. 8 square that is 64. It become root 89. So AB's value is root 89 units. Correct? So here we completed third question. Then focus on a fourth question. From the top of the lighthouse, an observer looks at a ship and finds the angle of depression to be 30 degree. If the height of a lighthouse is 100 meter, then find how far the ship from the lighthouse. So first we have to draw the proper diagram. When we focus on a diagram, here AB Here AB, it see here that AB is indicate the height of a lighthouse. Here C is the position of a ship, and here angle of depression is given. So when we focus here that AD is parallel to BC, that means angle DAC and angle ACB, it is a alternate angles, so they are a congruent. So here we have to write angle ACB also 30 degree. So here when we focus here, what is the given here? We have to find out here. Lighthouse height is a given. We have to find out how many ships are there. So just focus on here. In triangle ABC, tan theta, we know the value of AB and we have to find out the BC. That is the ratio is opposite side upon adjacent side. Means we have to focus on here tan theta, correct? So tan theta is nothing but AB upon BC. So put the value of AB here, tan 30 degree is equal to 100 upon BC, correct? But what is the value of tan 30 degree? Tan 30 degree is 1 upon root 3, 100 upon BC. So just shift that or cross multiply it, BC into 1, that is BC, and 100 into root 3, that is 100 root 3 meter. So what is the height of the, sorry, 100 and root 3 meter for the ship from lighthouse. So here we have to find out the distance between ship and lighthouse, that is the 100 root 3. So then focus on a question 5. Find the coordinates of the midpoints of the line segment joining P06 and Q12, 20. So focus here. Here, focus on that diagram. So what is that diagram here? Here A is the midpoint of a PQ. A is the midpoint of a segment PQ. So we have to use that midpoint formula. What is the midpoint formula? Focus here. X is equal to x1 plus x2 upon 2. Y is equal to y1 plus y1 upon 2. So here P consider as x1, y1, Q consider as x2, y2. So put the given value. So here we have to put it, that is x1 replaced by 0, x2 replaced by 12 upon 2. So 12 upon 2, that will get the 6. And here y1 replaced by 6 and y2 replaced by 20. So 20 plus 6, that is 26 upon 2, that will get here 13. So here the coordinate of A, that is the midpoint coordinate of A, xy, that is 6, 13, correct? Here we have to complete it second question. Then focus here our third question. Third A. Third A is again activity, each box having half marks. So focus on a diagram. So when we focus here first diagram, determine whether the following points are collinear. That is A minus 1, 1, B 0, 1, C 1, 3. So slope of line AB, that formula is y2 minus y1. What is your formula? Y2 minus y1 upon x2 minus x1. So we have to put that directly value 1 minus minus 1 upon 0 minus minus 1. So it become minus minus plus, so 2 upon 1. So our gate slope of a line AB is 2. We have to find out the value of slope of a line BC. So again we have to put that value, that is 3 minus 1 upon 1 minus 0. 3 minus 1, it become again 2. So 2 upon 1, it nothing but 2. So slope of line AB is equal to slope of line BC. That indicate that here B is the common point. So point A, B, C are a collinear, correct? So what is our conclusion? Points A, B and C are a collinear. Then focus on a second question. So focus on a diagram. So here circle is a given having in a figure chord EF is parallel to GH. Prove that EG is congruent FH. So what is the given here? Proof. Focus here, solution. Draw segment GF. When we draw here GF, we'll get the two angles. That is first one, angle EFG. EFG is equal to angle FGS because of alternate angle. Because these two sides are a parallel. So what is the alternate angle? Angle EFG congruent angle FGH. That is the alternate angles. Then focus here, angle EFG, it is also inscribed angle. So we have to use the inscribed angle theorem, that is half into measure of arc EG. Same where angle FGH is also inscribed angle. So we have to use inscribed angle theorem, that is half into measure of arc FH. But these two angles are a congruent, that indicate that LH's part are same. So RH's part are is also same. So measure of arc EG is equal to measure of arc FH. Correct? Means if it is a arc is a congruent, their corresponding chords are also congruent. So we have to find out chord EG congruent chord FH. Then focus here, we have to start the third B question. That is, we have to solve any two questions, correct? So total 4 questions are given. How many questions is given? Total 4 questions. So focus on a first question. What is the given? In the figure, M is the midpoint of a QR. Angle PRQ is equal to 90 degree. Then prove that PQ square is equal to 4PM square minus 3PR square. Correct? So focus on that diagram again. What is the given here? So this is the diagram. Here M is the midpoint is given, correct? That means RM is equal to MQ. So in a given, we have to write in triangle PRQ. Angle R is equal to 90 degree. M is the midpoint of a segment QR. Then what to be proved? We have to prove that PQ square is equal to 4PM square minus 3PR square. So first we have to start with one right angle triangle, that is PRQ, whole right angle triangle. So in triangle PRQ, angle R is equal to 90 degrees. So by using Pythagoras theorem. So what to be right here? PQ square is equal to PR square plus RQ square. Here we'll get the half marks, correct? But what is the given? Here M is the midpoint, that indicates that RQ is nothing but 2RM, correct? Means that RQ is replaced by 2RM. So we have to put that given value. So PQ square is equal to PR square, and we have to put, or RQ is replaced by 2RM. So here 2RM bracket square. This is our 2RM bracket square. So what will we get? That is PQ square is equal to PR square plus 4RM square. Correct? PQ square is equal to PR square plus 4RM square. That will get here equation number 1. Then again focus on a next triangle, that is in triangle PRM. Angle, just focus here, angle PRM. In that case again angle R is equal to 90 degree and PM is a hypotenuse. So we have to use again Pythagoras theorem, that is PM square is equal to PR square plus RM square. We have to find out the value of RM square. So what is the RM square? That PR square is plus, here when we change the side minus. So RM square will get the PM square minus PR square. This value we have to put in equation 1. Where we put here? Equation number 1. So what is that equation 1? See here, PQ square is equal to PR square plus 4RM square. That RM is replaced by PM square minus PR square. So here we have to put that value. So PQ square is equal to PR square plus 4 in bracket PM square minus PR square. So PR square as it is, 4 multiply that bracket. So 4 PM square minus 4 PR square. So PR square plus PR square minus 4 PR square, that will get here 3 PR square, but it is a minus sign. So PQ square is equal to 4 PM square minus 3 PR square. Hence the proof. We have to easily prove that, that is PQ square is equal to 4 PM square minus 3 PR square. Then focus on a second question. So what is the second question? It is one theorem. So what is our statement? Just focus here. Prove that if a line parallel to side of a triangle intersect the remaining side in a two distinct point, Then the line divides the side in the same proportion. Yes, correct. It is a BPD theorem. So we have to write the first statement properly. So we have to read again. If line parallel to a side of a triangle intersect the remaining side in a two distinct point, then the line divides the sides in a same proportion. So first we have to draw the diagram. So what is the diagram here? Just focus here. We have to draw a triangle ABC and line L is parallel to BC. Correct? So write down the in given part. Just we have to draw the diagram and write down the given. So in triangle ABC, line L is parallel to line BC and line L intersect AB at point P and AC at point Q. Correct? So what to be proved? We have to prove that AP upon PB is equal to AQ upon QC. So we have to prove that AP upon PB is equal to AQ upon QC. So here some construction is we have to done. That is we have to join that PC and PQ. So we have to start with the proof. So what is the proof? We have to focus here triangle APQ and triangle PQB have a equal heights. Focus on triangle APQ and triangle PBQ. We have to, it is one is a acute angle and one is a obtuse angle, but height is a equal. So that ratio it's related on base. So focus here area of a triangle APQ upon area of a triangle PQB is equal to AP upon PB. We have to write their equation 1, that is reason is areas proportional to their base. Then similarly, we have to focus on the second triangle or second ratio, that is area of a triangle APQ and PQC having equal heights. So area of a triangle APQ upon area of a triangle PQC is equal to AQ upon QC, correct? So here when we focus on that diagram, we have to focus on here height is equal, so that ratio is proportional to their base. So AQ upon QC, we have to write here equation number second. So areas proportional to their base. Then when we observe that diagram, PQ is a common base, correct? PQ is a common base and triangle PQB and PQC. Here segment PQ is parallel to segment BC, that is the given part. PQ is a common and PQ and BC is a parallel, that indicate that here both the triangle have same height, correct? Both the triangle have same height. That is which two triangle? Triangle PQB and triangle PQC have a equal heights. If they are a base are a equal, heights are a equal, that's area also equal. Means area of a triangle PQB is equal to area of a triangle PQC, that both the area are equal. That indicates that area of a triangle APQ upon area of a triangle PQB is equal to area of a triangle APQ upon area of a triangle PQC from equation 1, 2 and 3. So from equation 1, 2 and 3 we have to write the ratio LHS part is same. If LHS are same, we have to write here RHS also same. That is AP upon PB is equal to AQ upon QC. Hence the theorem of basic proportionality. Theorem. Then focus here. Third question, draw a circle of a radius 3.6 centimeter. Draw a tangent to the circle at any point on it without using the center. So it is the without using center concept, the first focus on a rough diagram. So here we have to draw that rough diagram here. It is concept, we have to use the tangent segment theorem concept use. So first draw, that is a 3.6 centimeter circle. We have to draw, take a center and draw a 3.6 centimeter circle. Then we have to draw one chord. Suppose BC is a chord. We have to draw it. And we have to draw one angle. This is an approximate measure. We have to draw angle BAC. Correct? This is actually inscribed angle. Then we have to take some measure. Correct? We have to take that measure. We have to draw that like arc. And take same distance at point C. And we have to draw the same measure of that arc here. Then take 2 points here. What is the distance between that two arcs? Same measure, we have to draw that arc here. And we have to draw that tangents, correct? So that is here, which concept is used? That is angle BAC, correct? Angle BAC is equal to angle BCD. That is angles in alternate segment. Angles in alternate segments. So it's required tangent CD, correct? So we have to complete that diagram by using the concept of without center using, correct? Having 3 marks. Then focus on fourth question. So what is the fourth question? Just focus here. A metal parallelepiped of a measure 16 centimeter into 11 centimeter into 10 centimeter was melted to make a coins. A metal of a parallelepiped of a measure 16 centimeter into 11 centimeter into 10 centimeter was melted to make coins. How many coins were made if the thickness and the diameter was 2 millimeter and 2 centimeter respectively? Read that question carefully. What is the given? A metal parallelepiped of a measure 16 centimeter into 11 centimeter into 10 centimeter was melted to make a coins. So how many coins were made if the thickness and diameter was 2 millimeter and 2 centimeter respectively? So focus here, parallelepiped, it is the shape of a cuboid. See here, parallelepiped, it is the shape of a cuboid. That is, what is the dimension? L, B and H. So L is 16 centimeter, B is a 11 centimeter and H is a 10 centimeter. For a coin, it is actual shape is a cylinder, correct? Most of students are confused and it's like a spear, but no, coins are a cylinder shape. So here dimension is radius and height. So radius is a given 2. Diameter is a given 2 centimeters. So it converted as 1 centimeter because radius is the half of the diameter. And here height is a given, that is a 2 millimeter thickness. That is a height 2 millimeters. It's converted same unit like a centimeter, that is 0.2 centimeter. Then how to find the number of coins? That is, we have to know if that parallelepiped is melt and convert its coin. That means the volume of a parallelepiped is equal to number of coins into volume of a one cylindrical coin. So formula will get the number of coins is equal to volume of a metal of a parallelepiped upon volume of a cylindrical coin. That we write here, volume of a parallelepiped, that is L into B into H, upon what is the volume of a cylindrical coin? That is pi r square H. So put that all given value, that is 16 into 11 into 10. That is L, B, H value is put here, 16 into 11 into 10. And again, what is the pi value? If pi value is not given, we have to put here 22 upon 7. Here, what is the radius? 1 into 1. And what is the thickness? That is 0.2. So focus here. 16 into 11 into 10. That's 7. Here it is divide part. When we change, it is a multiply by numerator. And 22 into 0.2. So replace the 0.2 decimal. So what will we get here? 16 into 11 into 100. That is that 0.2 is replaced by that here into 7 upon 22 upon 2. So cancelize it properly. 11 ones are 11, 2s are 22. 2 into 50. So 16 into 25 into 7. So it become the total answer will be 2800. So what is total coins will be formed? 2800 coins will be formed. So here we have to completely discuss first three questions. Then focus here question number 4, that is like an hot steps question, correct? So first read that question carefully. So in triangle ABC is a triangle where angle C is equal to 90 degree. Let BC is equal to A, CA is equal to B, AB is equal to C, and let P be the length of a perpendicular from C on AB. So prove that A is equal to CP upon CP is equal to AB. And what to be proved second? 1 upon P square is equal to 1 upon A square plus 1 upon B square. So just we have to draw that given. What is the given? We have to try the diagram here. So first we have to draw that diagram like that way. So in triangle ABC, angle C is equal to 90 degree. We have to draw a CM. That distance will take here B. BC is supposed to be A. Here CA is supposed to be B and BC is supposed to be C. That is the given. What to be proved? CP is equal to AB and 1 upon P square is equal to 1 upon A square plus 1 upon B square. So we know that if it is a right angle triangle is a given, we know that the area of that right angle triangle is half into that is base of their perpendicular heights. So we have to write area of a triangle ABC is equal to half into AC into BC, correct? Half into AC into BC. That is AC is replaced by the value B and BC is replaced by A. So we'll get the first equation, area of a triangle ABC is equal to half into B into A. Then we have to just change the position of that right angle triangle. We have to use the acute angle. That is we have to see here, that is a base BA base, and what is the height? CM is a height, correct? So we have to write here area of a triangle ABC, that is base AB and height CM, that is replace that value. So half into P into C. But that both the areas are equal because this triangle is the same. So area of a triangle ABC, both the equation are same. So we have to equal them. So half into B into A is equal to half into P into C, correct? So half of get cancelled, we'll get A into B is equal to C into P. That is CP is equal to AB. That will get the first proof. So then we have to just try to find out the value of P. So P is here, that C is multiply. When we change the side, it is divide. So what we will get the value of P? P is nothing but AB upon C, correct? Then here we have to squaring both sides. So P square is equal to P square is equal to A square B square upon C square. Take its invertendo. So 1 upon P square is equal to C square upon A square B square. When we take invertendo. But we know that C square is nothing but the hypotenuse. When we have to focus here in triangle ABC, just focus here. C square is equal to B square plus A square by using Pythagoras theorem, and put that given value, that C square is replaced by. So C square upon A square B square is nothing but B square plus A square upon A square B square. So here we write C square upon A square B square, that is B square upon A square B square, plus we have to separate the denominator. So A square upon A square plus B square. We'll get the in first process B square cancel. Here A square cancel. And that value is nothing but 1 upon P square. So here we write the second proof. 1 upon P square is equal to 1 upon A square plus 1 upon B square. Correct? Here our first 4 marks question completed. What is the second question? Construct triangle PYQ such that PY is equal to 6.3 centimeter, YQ is equal to 7.2 centimeter, PQ is equal to 5.8 centimeter. If YZ is equal to YQ is 6 upon 5, then construct triangle XYZ similar to PYQ. Just focus on that question. Here, both the triangle XYZ and PYQ, Y vertex is common. If Y vertex is common, we have to similarity concept second. Correct? Drawing the no need to calculation, no need to equating the same angles or sides. We have to find it. No need. We have to use the similarity concept. So first, try to draw a rough diagram. When we focus on YZ upon YQ, that ratio is 6 upon 5. That indicate that triangle XYZ is a bigger triangle and PYQ is a smaller triangle. Correct? When we have to focus that given triangle PYQ, which measure is given? PYYQ. That measure is given. Means this is our smaller triangle and we have to try to find out the second triangle which is a bigger. So take first here 7.2 centimeter YQ. Why we have to focus on Y vertex is common. So we have to take YQ 7.2 centimeter. Then take Y to P distance 6.3 centimeter and draw one arc here. Then take from Q to P, that distance is 5.8 and we have to draw that second arc here. That indicate we have to get that vertex P. Join this and we'll get the triangle here PYQ. Correct? This is a triangle PYQ. Then draw one acute angle here. That is that like way. Correct? We have to draw one acute angle. So total parts is 6. So we have to take at least 1 centimeter or 1.5 centimeter. Take that total 6 arc. Correct? That indicate Y1, Y2, Y3, Y4, Y5 and Y6. Then just YQ is 5 parts. So we have to draw here YQ, just join here 5 parts. And we have to try the same angle here also Y6. So we have to take one arc. Here we also take one arc, that is Y5 to Y6. We have to draw that intersecting arc and try to draw a line like way parallel, that is QY5. Same parallel line Z to Y6. So we'll get the point Z. Same construction we have to carry in above figure, that is we have to try the same angle, that is angle PQY like XZY, that is the having same measure because of similarity concept. So here how to draw that same similarity angle? So take Q point and draw one arc here. Same, take that same distance and take a point Z and draw that same arc here. Then again we have to take the measure of that 2 arc and same distance we have to take and Q to that point, that is the intersection point will get. And just joined or just try to draw a line or segment that is which is parallel to PQ. So focus here that PQ is parallel to XZ. So here we'll get the two triangles, that is triangle PYQ and triangle XYZ are a similar triangle. Correct? So what to be right here? It's required triangle PYQ and triangle XYZ. Here YY vertex is common, so we have to done that construction like way. Correct? Then focus on a third question. What is the given? In a third question, a gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with the length 5 centimeter and diameter 2.8 centimeter. So focus on that diagram here. It is a gulab jam shape, that is middle part is a cylinder shape. Correct? Middle part is cylinder and here like a hemisphere. So two hemisphere is here. So given one gulab jam is a combination of a cylinder and two hemisphere. Here total length of one gulab jam is 5 centimeter and diameter 2.8 centimeter. So what is the radius of a cylindrical part? That is radius of a hemispherical part. Same. That is r is equal to diameter is given. So we have to convert into radius. That is 2.8 upon 2. It will get the 1.4 centimeter. Then find out here height of a cylindrical part. So height of a cylindrical part is h. We have to consider here total PQ height is a given. So PQ minus both the radius we have to hemispherical part cut here. So 5 minus 1.4 1.4, that is we have to cut 2.8. It become height 2.2 centimeter. Then we have to just try to find out volume of a one gulab jam. That is nothing but observe the proper diagram. That is 2 into volume of a hemispherical part plus volume of a cylindrical part. Correct? So volume of a one gulab jam is nothing but 2 into volume of a hemispherical part plus volume of a cylindrical part. That is we have to write proper way. Put that the formula, that is 2 into what is the volume of a hemispherical part, that is 2 upon 3 pi r cube. And what is the volume of a cylinder, that is pi r square h. So 2 into 2, that is 4 upon 3 pi r cube, and here pi r square h. So take pi r square is a common both the case. So pi r square in bracket 4 into r upon 3 plus h bracket close. Put the all given value, that is 22 upon 7 into r square is replaced by 1.4 into 1.4 in bracket 4 upon 3 into 1.4 plus 2.2. So here 22 upon 7 we have to shift the decimal. So 14 upon 10 into 14 upon 10, 4 upon 3 into 14 upon 10 plus 22 upon 10. So here we have to get cancellation. 7 ones are 7, 2s are 14, 2 ones are 2. Cancel here. 5 2s are 10. Here 5 ones are 5, 2s are 10. Then here in bracket side, here what we write here 10, here 30. So multiply by 3 here. So we have to what will get here first. Here the denominator is 15. Here we'll get the denominator 5. So here we have to use the same the denominator process. So 154 upon 25 into 61 upon 15 means we have to try to the same the denominator. That is in that figure we have to multiply numerator and denominator by 3. So it becomes 61 upon 15. So what will get that multiplication? Will get the direct answer 9394 upon 375 centimeter cube. So volume of a 45 gulab jam, we have to find out the one gulab jam value. Total 45 gulab jam is given. So 45 into 9394 upon 375, it become 28,182 upon 25. It become approximately 1127.28 centimeter cube. Since one gulab jam contains sugar syrup up to about 30% of its volume, hence quantity of serum found in the 45 gulab jam, that is volume of that gulab jam into 30%, that is 30 upon 100, it become approximately 338.184. See here 338.184, that is approximately 338 centimeter cube. So what is the total volume of a gulab jamun? That is 338 centimeter cube. Then we have to just focus on question number 5. So what is the question 5? Solve the following sub question. Here first question is, it is in trigonometric part, that is if x is equal to a sin theta, y is equal to b tan theta, then prove that a square upon x square minus b square upon y square is equal to 1. So it is the totally elimination method. We have to try to remove the theta. So here what is the given? Just focus here. x is equal to a sin theta given and y is equal to b tan theta. Just try to find out the value of sin theta, that is a is replaced here. So x upon a is equal to sin theta. And here we write y upon b is equal to tan theta. So sin theta is we have to write in a cosec theta form. So we have to write a upon x is nothing but cosec theta. Same where tan theta is converted by cot theta, that is b upon y form. Because we know the relation between cosec and cot theta, that is one identity. So what is that identity? That is cosec square theta minus cot square theta is equal to 1. So put that cosec theta value, that is a upon x bracket square minus b upon y bracket square is equal to 1. So put that value here, squaring them. So a square upon x square minus b square upon y square is equal to 1, since it is true. This is a very simple question. And then focus on that last question, second. So what is the last question? We have to focus here. In triangle ABC, AB is equal to AC. D is any point on a BC. Prove that AB square minus AD square is equal to BD into CD. So focus on a diagram. First, diagram is here. Focus on what is the given. That is in triangle ABC, AB is equal to AC. D is any point on a segment BC. What to be proved? AB square minus AD square is equal to BD into CD. So solution, draw. A is perpendicular to BC. If AC is equal to AB, that is the given, that is the A is a point of a perpendicular, that is the A is perpendicular triangle bisector of a triangle ABC. That indicate that C and EB part is the same. That we have to use the perpendicular bisector property, correct? Because it is a equidistance from C and B, A point, correct? In triangle AED, angle E is equal to 90 degree. Just focus on which triangle is given. Triangle AED, this one triangle, correct? So here in triangle AED, angle E is equal to 90 degrees. So by using Pythagoras theorem, that is AD square is equal to AE square plus ED square. So in triangle AEB is equal to angle E is equal to 90 degrees. So AB square is also we have to write the same like equation, Pythagoras theorem, AE square plus EB square. Subtract equation 1 and 2. So AB square minus AD square is nothing but A square get cancelled because of subtraction. So AB square minus AD square. So we have to use that formula here. EB square minus AD square, that is A square minus B square formula, that is A plus B in first bracket, A minus B in second bracket. So EB plus ED and EB minus ED. But EB is nothing but EC. So EC plus ED, that will get the CD, correct? EC, just focus on here. EB, that EB is nothing but C. So EB is replaced by C. So C plus ED is nothing but CD, correct? So here we'll get C plus ED, that is nothing but CD, and EB minus ED. Just focus on diagram. That is EB minus ED is nothing but the BD. So we have to easily prove that AB square minus AD square is equal to CD into BD. Hence it is proved. So we have to discuss all the question for a second prelim. So all the best for third prelim. Thank you so much.